nitrate. Let's add some sodium chloride. It's going to make some silver chloride and some sodium nitrate. Okay? Do we agree that there's a precipitate here?
Yes.
Yes. Which of the two products is the precipitate?
Silver chloride.
Silver chloride. How do we know that sodium nitrate is not the precipitate? Has an alkali metal and it has a nitrate. Okay, good. So everything else is aqueous. All right. So this is the molecular equation and it is balanced. Okay? So now let's do the ionic equation. We've got a silver, a nitrate, a sodium ion, a chloride ion. Leave this together. We've got a sodium ion and a nitrate ion. Okay. And then the net ionic would be silver plus chloride makes silver chloride. Everybody good with that? Yes? Okay. Now the first stoichiometry problem I asked you to do was to using a solution of each of these to figure out how many grams of precipitate you need. Which type of chemical equation would be the easiest to use for that problem? The molecular, the ionic, or the net ionic? Which would probably be the easiest? The net ionic? It could be, okay? Or really, would the molecular work?
Yeah.
It would. Okay, so let's use that for the first part, okay? Now, if you remember, the instructions were that you had 100 milliliters of each reactant solution and the concentration of each was 2 molar, right? Okay, let's remind ourselves of what we need to start our stoichiometry with. Do we want to start it in grams with our stoichiometry? Is that the best unit to start with? How about milliliters? How about molarity? Moles. We want to get to moles. No matter what we're given, if we have moles, that is the best, right? Okay, so real quick, let's remind ourselves. Isn't molarity moles per liter?
Yeah.
So, wouldn't molarity times liters equal mole? Okay, so let's do that real quick. And I think we can graduate to where we do that in our head. 100 milliliters. How many milliliters are in a liter? 1,000. So 100 divided by 1,000 is what? 0.1. So we know we have 0.1 liters. And it's 2 molar. So what is 2 molar? Molarity times volume. How many moles do we have? 0.2. Okay. So we have 0.2 moles of this, 0.2 moles of this. We got to figure out how many grams we're going to get. Okay? Here is my question. Which one is our limiting reactant? Okay? And I really don't want you to do a bridge. I want you to think through it. Okay? Don't call out the answer. Let me say this to you. Remember, when you balance, because there's an understood one here and an understood one here, that means that every time, however much AgNO3 you have, you need, in terms of moles, you need the same amount of NaCl. Is everybody with me? That's what that means. Okay, so which is your limiting reactant? Okay, I got one vote for the silver nitrate.
Silver nitrate.
Does everybody agree that silver nitrate is the limiting reactant? It's the same.
Oh.
So,
But isn't it also dependent, like, is it, because it's the same amount.
yep, because the balancing is exactly even, you need exactly the same amount of each. And because we're given exactly the same amount of each, won't they both run out at the same time? So really, rather than saying there's no limiting reactant, I think it's best to say they're both the limiting reactant, right? They will both run out at the same time. So, if we are now going to set up our bridge so we can solve for silver chloride, which do we start with? It doesn't matter. Pick either one. So, we have 0.2 moles of, let's just do silver nitrate. And now I'm going to kind of avoid the bridge a little bit more. We'll go back and we'll write a whole bridge. But in your head, can you tell me how many moles of silver chloride we would make? if you started with 0.2 moles of silver nitrate, how much silver chloride would you make? 0.2. You are allowed to do that kind of simple calculation in your head. We did that so quickly because there's a 1-to-1 mole ratio, right? That's why we were able to do it. Now, we need to convert this to grams. 1 mole of silver chloride is, the silver, you're going to say 107.9. And is everybody rounding chlorine's molar mass to 35.5? You need to do that. Like on here, it's 35.453, blah, 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 blah. Let's round it to the tenths place. So take your hundredths number and round it accordingly. So that would be 35.5. So this ends up being 143.4 grams. Now, let's go a little bit further. I don't want you to use your calculator. Okay? If we cover up this point, can everybody take 2 times 143.4 in their head? Yeah, tell me the answer. 286.8 grams of AgCl. I keep forgetting that's Ag. Now, because it's 0.2, what am I going to do to my decimal? Move it over. And so the answer is 28.68 grams of silver chloride. I want to convince you that you really can do more without a calculator than you think.